Alright, adding whole numbers. Addition is basically starts from what we did in first grade. It doesn't really get much more than that. If you have one apple plus three apples, you get four apples. We put numbers in front of stuff in order to tell us the value of our quantity, the number of those items that we have. So if you have an apple, we have one of them. If you put a 3 in front of it, it means you have 3 apples. It's just a way of denoting that. And then we get 4 apples. So when you read stuff, that's how you want to look at it. A 5, it tells us how many monkeys we have. 5 monkeys plus 3 monkeys is 8 monkeys. I'm not going to draw because I can't. So I'm just going to put 8 monkeys. And then so read this one. Wrong. I know I shouldn't say wrong, but it is. We get this tied up to saying 4x and 7x because it works sometimes in algebra to make things a little bit clearer. But when we're talking about addition, you want to say 4x's and 7x's. It's not 5 monkey. It's 5 monkeys. It's plural. So 4x's plus 7x's is a total of 11x's. This is why we get them. It's the total quantity that we have. It's the total number of x's. And they have to be the same. The 3 monkeys plus 2 monkeys is 5 monkeys plus 2 apples. And you're thinking, well, why am I going into all of this if we're just going to add some whole numbers? You just line them up and go. It's because we need to line them up. You have 4 different place values here. And what we have is you have a 2. That's the ones. You have a 3. That's in the tens. You have a 4. That's in the hundreds. And then you have a 5. That's in the thousands. We have 4 different things. Each of these numbers, the 2, the 3, the 4, the 5, the 8, the 1, and the 2, they all represent some value of something. So our standard algorithm, we're supposed to take and line the numbers up. And that's the reason, so that our 1s line up and we have 4 of them. Our 10s line up and we have 4 of them. And our hundreds line up and we have 12 of them, which makes 1200. That's why we have to carry that 1. And then 1 plus 5 is 6. So it's 6,244. We had 4 1s, 4 10s, 2 hundreds. We actually had 12, but we had to carry that 1 over here because that represents 1,000. It's now in the thousands place, right? And then 6. And we're going to do it in expanded form so you can kind of see this a little bit better. So, alright, so what we have over here is 5,000 plus 800 plus 10 plus 2. That's our number. It's 5. The 5 represents 5,000. The 8 is 800. The 1 is 10. It's 110. And then a 2. This is our expanded form that we've done before. And then we have 400 plus 30 plus 2. So we get 2 plus 2. That's a total of 4. Oh, what's 10 and 30? That's 40. And then 800 and 400, that's 1,200 plus 5,000. So when we put these together, it's 5,000, 1,200, 40, and 4. Which is why you notice that 1 just carried over. And we get that same answer. Alright, there are other ways. I mean, the standard algorithm's great. Expanded form works really well too. This is our standard. If you're going to add 2 numbers, it's like the straightforward, just line them up and add them. This is how we always do it. But sometimes you want to do stuff a little bit quicker. So this is using a number line. And what it means is you can start at 121 or 49. I mean, if you remember back when you were in grade school, you probably said, oh, put 121 in your head and then count 49. And that's what we're going to do. You put 121. And you can pick any part of the number. So you got to think 121. What will get me to the next base 10? What's the next 10? Which would be 130. Can I pull part from there? And yeah, you can take a 9. And now you're at 130. And then what do you have left? Well, if you take away a 9, you're left with 40. Okay, well 130 plus 40 would give you 170. It's another way of doing it. You can just add the parts together. So you're not actually carrying numbers or anything. You're just thinking, oh, well, the 9 put me at 130, and then the 40 is going to move it up. This is more of a mental math.